You're on lesson 2, multiplication of numbers in exponential form. It's on page 11 of your workbook. So it's the first page of your lesson 2. In the box, you are given what is called the product rule. And this rule says that in general, if x is any number and m and n are positive integers, then x raised to the m power times x raised to the n power is equal to x raised to the m plus n. So you have to notice that those two bases are the same. That's why this works. It's basically saying, like right here, that if you have x and it is multiplied times itself m times, and then you're multiplying that times x multiplied by itself n times, then you could just add m and n to make the equation or expression simplified. Okay, so exercise 1, and there's no instructions here, but we are going to say that the instructions for this are just to simplify it. So if you have 14 raised to the 23rd power times 14 raised to the 8th power, you have 14 raised to the 23rd plus 8 power, which is 23 plus 8 is 31, so it's 14 raised to the 31st power. Okay, the next one, exercise 2, and we have two negative bases, and notice that they're in parentheses. That's very important. We talked about that in the last lesson, that you keep them in parentheses as well as fractions in parentheses. So negative 72 to the 10th times negative 72 to the 13th is negative 72 to the 23rd power. I could have simplified it first by saying negative 72 to the 10th plus 13, which is equal to that. Okay? I just want to show you the process. Exercise 3 is 5 raised to the 94th plus 78, which is equal to 5 raised to the 172. Exercise 4, we have negative 3 raised to the 9 plus 5 power, which is equal to negative 3 raised to the 14th. Make sure you keep the parentheses. And then exercise 5, you have letters instead of numbers, but notice that the exponents are the same, I believe, on all of these. So you have a raised to the 23 plus 8 power, which is 31 power. For this one, f raised to the 23rd power. For this one, b raised to the 172, which is 94 plus 78. And exercise 8, let x be a positive number if negative 3 raised to the 9 times negative 3 raised to something equals negative 3 times, or raised to the 14th. What is x? And so x would be, just like over here, 5. Which would make that the same as the exercise 4. Okay? And then on the back, of the workbook page, you see what would happen if there were more terms with the same base. Write an equivalent expression for each problem. So basically you're just simplifying this as much as possible, and I think if they're just write an equivalent expression. So I believe for this we could just go 9 to the 4 plus 6 plus 13. I don't really even think we need to solve that. You could if you wanted to, but really we're just simplifying the expression. And then 2 to the 3 plus 5 plus 7 plus 9. And can the following expressions be written in simpler form? And that's what we're looking at there. And if so, write an equivalent expression. If not, explain why not. So we are on exercise 11. So we have 6 to the, okay, so we have 2 different bases in here. You see this is a base and this is a base, so you could combine those two. So you could combine it to say like 6 to the 5 plus 14th power times 4 to the 9 plus 3 power, which is the other base. Okay, so we can't combine those two bases, but we can the powers that have an the powers that have a base that is the same, you could combine. Okay, so that's as far as you can go. I mean, you could combine the 14 plus 5, like you could have 6 to the 19th times 4 to the 12th, and that's okay, but that's as far as you can go. All right, 12. So we have this and this have a base of -4, so we could say -4 to the 2 plus 3 times 17 to the 5 plus 7. Okay, and then exercise 13, we have 15 and then we have 7, so we could say 15 to the 2 plus, and there's nothing there, so it's a 1. 15 raised to the first power is just 15. 2 plus 1 times 7 to the 2 plus 4. And exercise 14, there's 2's here, and then there's 3 2's and just 1 8, so we have 2 to the 4. Sorry, there's some equal signs in there that I was ignoring. That's silly. So on this one, if we go back to the instructions, right, you're asking if these can be written in a simpler form. So yes, it's just doing the work for us. This is the same as this, which is the same as 2 to the 4 plus 6, which is 10. And so important to see that even though this is a different base right here, 8 to the second power is the same thing as 2 to the 6th power, because 8 to the second power is 64, as is 2 to the 6th power, 2 times 2 times 2 times 2 times, okay? So that's why you can do that. That's why it looks a little bit different. Okay, and exercise 15, similarly, 9 is 3 squared, so you're just combining 3 to the 7 plus 2. In exercise 16, there's no way to adjust this one, right? We cannot simplify it. Bases are different and cannot be rewritten in the same base, like how 8 squared could be rewritten as 2 to the 6, but you can't rewrite these in the same base, so cannot be simplified. All right, and then exercise 17. Moving along, and let x be a number. Rewrite the expression in a simpler form. So you have 2 to the x to the 3rd and 17x to the 7th. So what you can do is you can multiply 2 times 7 because there's the same base there, and that's going to be 34x to the 3 plus 7, which is 34x to the 10. And then exercise 18, which is let A and B be numbers. Use the distributive law to rewrite the expression in simpler form. So A squared, we're distributing this. If you need a review of the distributive property, you multiply A times A and then A times B. So we have A squared plus A times B. Oh, sorry, that is my dog. He's angry. Okay, and then exercise 19 and 20 are similar. Oops, I just lost a paper. 19 is same thing, distributive law. So this is b times a, or you can write it with a first if that bothers you, because multiplication's any order, and then b times b, which is b squared, so plus b squared. And then the last one is distributive property. This one's a little bit of a challenge, so if you got it right, that's awesome. If not, don't worry about it. It's not really what we're necessarily working on right now, but this one is going to be a squared, because you multiply those first, and then you multiply these, so plus a times b, and then you multiply these plus a times b, and then you multiply these plus b squared. So you could simplify this as a squared plus 2ab's plus b squared. Okay, and likewise, we're not going to spend that much time on this, but because it is definitely a challenge. But that would be the solution. And that is correct also, it's just not simplified enough. Okay, I'm going to pause the video before we get to the quotient rule. The second video will be on the quotient rule problems.